Good morning, everyone. Welcome to our advanced practitioner call this morning. Our presenter today is Eric Krueger. He's going to be visiting with you on the topic of Cherwell performance tuning. Just to let everyone know in advance, we are recording this session, so we'll send you a copy after. If you'd like the slide deck, we'd be happy to share that as well with all attendees today. We may go past the top of the hour. This is a great topic, and lots of times there's a lot of questions. So if you have to drop at the top of the hour, you're welcome to watch the recording at another time. For anyone who may be unfamiliar with StrataCom, I'll give a very brief overview before we jump into today's topic. StrataCom was founded in 1997. We do IT service management. We've specialized in some of the popular solutions over the years. Cherwell as of 2012. We were one of the first Cherwell partners on when they launched their program in 2012. And we're one of the bigger partners as far as services go. We do a wide variety of Cherwell professional services. And more recently, we've also started developing some add-on solutions. We've got a mobile solution, Kanban boards for Cherwell, and coming soon will be a smart chatbot. So stay tuned if you're interested in any of those. With that, I'm going to turn it over to Eric Krueger. He is a principal consultant here with StrataCom and one of our founding owners. If you have questions for Eric as we go through, feel free to put those in the chat feature, and I will interrupt Eric as we go along with any questions you may have. We'll also keep the line open at the end of today's presentation for a question and answer session as well. Again, this will be recorded. We will be sharing slides. Enjoy the content. Eric, it's all yours.
All right, thanks, Laura. So I'm gonna do my performance tuning presentation. So let me fire this thing up here. So some of you may have seen this at user groups. This will be kind of an extended version of that because I don't usually get it as much time in the user groups to do the whole thing. So I'm going to go through the whole thing. It may take over an hour, especially if we have questions, but that is fine with me. I've got the time. And I want to make sure I get all the questions answered. And also, we'll make this slideshow available. I'm not 100% sure if we have a place to put it, or if you might just have to email Laura and she can send it to you. I've got some GIFs in here to make it a little more interesting, so I'll take those out in the version that gets sent because it's really large. So, and okay, so we will go over this. If you have any questions, you can email Steve Day or Laura Walker about this. Their emails are right here. They'll be in the presentation that you get. But if you want the presentation, probably email Laura. And our agenda for today, I'm just going to give a little performance overview. Hopefully you'll learn one thing today. So I've got a few sections. So I've got some query performance tips. These are general tips about query performance and how to write queries effectively so they perform the best. And then I've got the biggest bulk of the presentation on effectively creating indexes from the health check. So I'll kind of show you how to run the health check and then how to create indexes from that health check. That's a big one that I have worked with a lot of customers that do that incorrectly, or they've worked with Cherwell support and they've done it incorrectly. So they end up with lots of extra indexes that confuse the SQL optimizer. I've got some one-step performance tips, some really simple things you can do to help performance in one steps, and then some IIS performance tips. That's mostly going to be for on-premise. I believe Cherwell does these on their AWS implementations of IIS. So if you're hosted with Cherwell, you'll be covered for that last section. And just a little spiel for our native mobile and Kanban. So we've got a native mobile client for Cherwell, Kanban boards for Cherwell, Gantt charts for Cherwell, coming out with a smart bot for Cherwell. These are just different UIs for Cherwell that we're writing and customers are using. So if you have a mobile need or want to try out the Kanban, or you're like a PPM and ITPT and want a Gantt interface, contact Laura or Steve and we'll get you set up on a test instance of our mobile Kanban framework. I'm going to skip that. All right, so just a little overview of performance. So Cherwell CSM is primarily reliant on the underlying database. So it runs on Microsoft SQL Server. If you're having performance issues, generally they're going to be database related. There's some things in Cherwell, primarily foreign keys, that can cause some problems that are not easily fixable with the database, but most of the issues you're going to see with performance are going to be database related. So I will go over a few things you can do in the application for tuning, but most of the issues can be fixed by tuning the database or getting more database horsepower if you're on premise. If you find that you have performance problems and you're hosted, you can also request the hosting team to up your like your AWS level of service. So we've had some customers that have done that successfully and noticed performance increases. So of course, this includes portal performance issues. And just about everything in this presentation will be the same for on-premise or hosted. So if you're on-premise or hosted, there's a couple things in here that are going to be more specific to the on-premise that the hosted team just won't do. Some of the special indexes I'll talk about. But most of it, the meat of it is either. Windows client general slowness probably cannot be fixed. I don't know what's wrong with that thing. So if you're saying the Windows client is slow and the web client is fast, the Windows client is just slow. I don't know, that it's kind of a beast. So there's a few things you can do with caching, turning off caching. But if a lot of customers now are remote, and it just takes a long time to load that Windows client up, and the Windows client is just slow. The Windows client is just slow. So, all right. So here's some guidelines for creating good queries. So the main guideline I'm going to focus on is avoid using not equals. So you'll find this not equals in a lot of out of the box queries that are in Cherwell. Super common to use not equals closed. But what happens when you use not equals is SQL Server will not use an index and will perform a full table scan on that table, or it might do a full index scan. Either one. If you're a DBA out there right now, don't be upset with me. I'm trying to explain this to Cherwell admins. So, but essentially, if you use a not equals, the database has to read the full stack of data that column sits in. So if there's no index for it, it'll read the whole table. If there's an index with that column, like status, it'll read the entire index, and it's got to drop things out. So it just has to plow through an enormous amount of data to get those records for not equals. So you're better off changing those queries and including multiple records in the where clause than excluding records. Same thing with null. Null would be an unusual one, but some searching for empty, like if you're searching for all the customers that have an empty phone number, it won't use an index either, but there's not much you can do about that query. It's the only way to find customers without a phone number. So here's a good example. So this is status. This is a common query that we see in Cherwell. It comes out of the box. A lot of customers do it. So if you have status not equals closed, you should think about replacing that where status equals new or in progress or assigned or reopened or pending or resolved. So it's a longer query, right? It's a longer where clause, but it will use an index which can be sorted, and the SQL Server will end up reading a lot less data to get your records than if you use not equals. So this is the primary issue I see with queries in Cherwell. So like I say, it's better to have hundreds or thousands of items using an OR clause and one item in the not equal clause, especially if you have millions of records. The more records you have, the more important this becomes. It's pretty easy for the SQL engine to read in 100,000 records and sort through those in memory. But if you have 10 million, it's a lot more work to read through those. So there are some things you can do where combining not equals with an equals will help. So example, if you've got owned by team equals group 4 and status not equals closed, that will help because then it'll pull all the records out of, say, incident where the owned by team is group 4. And if there's an index for that, it can use that index. And then it can drop out the not, the closed ones. So it's still not going to be as efficient as if you had the equals and ors, but it will, if you've got a million incidents and let's say 25,000 have been assigned at some point to group 4, it's only going to read those 25,000 records instead of the whole million. So that is a better scenario. So you can do some things to help, but it's still best practice not to use that not equals if if possible. So especially as your tickets increase, it's just going to be worse and worse. Okay, so in order to do some of these indexes, we need to run the health check. So if you haven't run this before, feel free to run this on the call. Version 10 added a few things. Really, all you're really looking for in the health check is the missing index recommendations, at least for performance. So the proper procedure: run this health check, implement the recommendations. I usually recommend waiting a period of time, a week or so, and rerunning. But in actuality, you could wait a day or even a half a day. Things will start to show up right away on that health check after you implement indexes. And once you put them into production, if you rerun the health check 2 hours later, and things that were not in the health check before will start popping up. So just a little for on-premise customers, you've got to have the view server state in order to run the health check and get the index recommendations. So make sure you have that. If you don't have it, you'll get like a blank index recommendation section. So to run it, it's under categories on the left pane. Click performance, and then run the health check. Click OK. So it's right over here. Performance, run health check. This is an older health check. Really, we're looking for that missing index rule. That's really what we want. So especially on 10, the 10's health checks do a lot of other things that could take an extremely long time to run. So you may want to uncheck everything except the missing index rule. That's really the one that we're looking for in regards to performance. So once you run the health check, there's a few things in here. The first thing is uptime in seconds. Now, I like to take a look at that just to see how long. This is the uptime from when the SQL Server was restarted. And one of the things the health check does is all of the stats on the queries that are run are reset when the SQL Server is restarted. So once SQL Server is restarted, all of the queries that you have. So you can take this uptime in seconds, figure out how many days the SQL Server has been running, and that will kind of tell you. And I'll show you the total cost, but that'll tell you total cost and how important that is. And then down at the bottom, I've also got server max memory. So this is going to be, you can check this if you're hosted or on-premise. I like to recommend the server max memory be set about the same size as the database, or even a little bit more, just because SQL Server can do page caching. Unfortunately, it doesn't cache query results. It's not Oracle. But it can cache page retrieves. So if you can get all those SQL Server, the database pages into memory, it can actually churn through those in memory instead of on disk, and it'll be a lot faster. So, but the only way to ensure that everything is in memory is to have the server's maximum memory to be at least the size of your database. So you may or may not have luck with Cherwell hosting getting that number raised. If you're on premise, you can work with your database team to do that, or get it a certain percentage of the database. So figure out how big your incidence table is and your approval table and some of these tables that are hit, and make sure it's at least that size. Okay, so there's a few things in the health check before we get to the index. One is the caching tables. So these are tables which could be cached for the FAT client. Only available for the desktop client. One downside of caching tables is that it takes a longer time when you start up, because it does the caching when you start the client up. So that long load time when you start that Windows client, some of it is tables being cached down to your cache on the local machine. So if you've got some big tables there and a very large like cache file for your Windows client, you may want to uncheck some of these. So in the health check, this is just a list of what the health check is recommending for caching. And then you can kind of make your own decision on whether or not to cache. If you want to cache tables, it should be things that don't change, because the cache is not going to be refreshed if something changes in that, because it just doesn't go to the database. It goes right to the cache. So it's nice if you've got smaller tables that don't change, like service category, subcategory. Those are good things to cache if you want to do caching, because they rarely change. You'll basically get a new copy every day, and they're used quite a bit and quite a few things. So it saves you a round trip to the Cherwell server to look those things up. So in order to cache it, you just go to the business object properties, go to advanced, and check the cacheable. And if you want to uncache it, you can do the same thing. Okay, so now this will be kind of the heart of the presentation, and this is the missing index rule section. So what happens is Cherwell runs a SQL, some SQL store procedures that hit the system tables in SQL Server, and SQL Server actually stores all of the index recommendations. So if a query comes in and the SQL engine says, oh, I don't, if I had an index for this query, I could find these records a lot faster. And so it will actually kick out a recommended index for that query. So some newer versions of SQL Server actually do even more, quite a bit more. They'll actually store the query and recommend an index by query so you can tie them back. Cherwell has not built that into their health check yet, but the newer versions of SQL Server can collect a lot more information about these queries. So I do recommend to implement these missing indexes. But the number one mistake I see is that customers just kind of blindly implementing these indexes. And I'll show you why that's a problem. I've got some nice examples that I'm going to run through to show you how SQL Server recommends indexes and kind of what the problems with the recommendations are, and then how to fix those issues. So I will show you how to do it right. And I say you may do more harm than good, because a lot of the indexes that are recommended are just essentially the exact same as indexes that are already in the system, but they may have it like, say, an additional include field or something that's really doesn't make the index any different. It's a minor difference. But when you have indexes that are the same, the optimizer has to choose which one to use. And sometimes if you have too many, it just won't use one. The optimizer will say, it's going to take me longer to figure out which index to use than it is just to scan the table. And so sometimes you'll lose an index, a scan or seek, because you have too many indexes that are essentially the same and confusing the optimizer. Okay, so this is what the missing index section looks like in the report that Cherwell kicks out for SQL Server. So, and I've got the Microsoft guidelines below. You can take a look at these if you download this. But basically, the equality columns are first. So that equality usage column, those are everything in the where clause that equals. And then the inequality is everything that's not equal. So greater than, less than, not equal to. So those are the fields that are in the where clause. And then the include column, that very last column, those are fields that the query is asking for that are not in the where clause. So for example, that second row down, it's probably saying, give me all the incidents where the customer display name equals Sam Smith, the status not equal to closed, and I need the rec ID and the customer approval email. So what it's saying is, in that case, is if you put those include columns in that index, it won't have to go over to the table to look them up. So now an interesting thing about the order of these fields, say in the equality usage and the inequality usage, they are in the order that they were added to the table. So they're not in like any sort of intelligent select the smallest number of rows, put the largest cardinality first. They're basically just in the order that they were created. So there's no intelligence behind that. So you can also sort those around, move those around in the order that they're added to the index, to whatever makes the most sense. And one common thing that I see is customers see a field that needs to be indexed, and they say, well, there's already an index that has that field. Is that one should work? I'm good. But if that was the case, that field probably would not have shown up in that index recommendation. So for my example is if you have owned by, if it's recommending an owned by index, and there's already an index that includes status, open date, and owned by, you should probably still add an owned by index, because being third in the list, an owned by in that index isn't a good place to be. That the optimizer may use that index, but it's not sorted by owned by, so it essentially has to read the entire index in order to get those columns. So it does what's called an index scan, which scans the entire index, which is more efficient than scanning the entire table because it's a lot less data, but it's still pretty inefficient. And the larger your data gets, the slower that'll get. So the query optimizer, it may or may not use that index. I guess it kind of depends on the data size. But either way, even if it does use that index, it's not going to be sorted. It's going to be pretty inefficient. So either create an index with owned by, or put owned by first. Just fix this index and put owned by first, which I probably would do in this case. Although open date would maybe be a better one to put first. Kind of depends on if it's greater than or less than, or if you're looking for a specific date, then open date for sure should be first in this query, but owned by could go first in this query. But it's a little, this is where it gets a little complex. It's more art than science. So don't believe what you've heard. You may have heard that don't worry about any indexes where the cost is less than 5 million, only focus on those costs that are above 5 million. If we look back here, the total cost is that first column in this table. So you can see here, this, I probably just ran this on a test system, but the total cost is, the top one's 28,000. So that's far less than 5 million. But you can see the average user impact. That's like the percent of improvement. So they're saying basically, it's not really percent of improvement, but out of 100, with 100 being the best, how much would this query improve if I added this index? Well, it would improve 99.47 out of 100, where 1 would be the worst. So you can see the bottom one, the improvement's only 25 out of 100. So that's not much of an improvement. So that whole thing about 5 million is it's really a bad recommendation, because that's just the total cost per query times the number of times it's been run. So if you've got something with a cost of 0.5, but it's been run 10 million times, it's going to have a cost of 5 million, but the cost per query is super low. So you don't have to worry about that. Just ignore that. Just basically work from top to bottom in that index recommendation table. And so that's why it's also important to look at that uptime seconds, because you can figure out how many days this has been run. And if your costs are really low and it's been running for 5 months, maybe they're not a problem. If they're all in the 10,000s, you probably have really low costs. But the thing about that index recommendation is SQL Server wouldn't put an index in there if it didn't think it needed it. So if they're in there, you should at least take a look at it. So some people ask, well, won't adding too many indexes affect performance? And I say not really. As long as the indexes are different and not the same, so the optimizer can easily tell which indexes to use for the queries, you shouldn't have to worry about it. Additional indexes, they do cause performance hits on updates and inserts, but until I start to see updates and inserts in like the top 25 poorly performing queries, I'm not going to worry about it. Indexes do take up additional database space. Of course, they're a copy of the data that's in the table stored in an index. So your database may get bigger as you add indexes. And if, like I said, if updates show in the top 25 query section, you may have too many on that table. So I personally have never seen it happen. Usually adding an index for querying in a system like Cherwell far outweighs the update and insert potential issue. And Cherwell's not really that transactional of a database. If you were doing 100,000 inserts a second, then it makes a big deal. But most Cherwell customers maybe they're adding 1 million incidents a year. So incidents per second is really low, less than 1. So the health check will give you some indexes that are not used. Feel free to remove them. So you can see the ones I've got highlighted. All of them except one was used 4 times, but most of them have been used. There's no seeks, there's no scans, there's no lookups on there, but there's lots of updates. You can see these updates, these indexes. I think they're all for journal that I have. Yeah, they're all for journal. They've been updated almost 90,000 times, but never been used. So you can go in and find those and remove them. And they should have the same name. in Cherwell as they do on this form. So I see that a lot. There's even a lot of out-of-the-box indexes that are just never used. Maybe they were put in, especially for customers that have older versions that have upgraded. Cherwell has changed how they do some things. So some of these indexes are just sitting out there. And on a table like Journal that gets really big, these extra indexes can take up quite a bit of extra space. So I recommend removing them if you see these numbers in here. So, and this is unfortunately, Cherwell doesn't have a great in the health check. A great way of kicking out the indexes that are unused other than this user updates one. And this is just showing the most updated indexes, and then it actually shows if it was used or not. So it's not the best, but it's a decent way of getting those high update tables, getting rid of unused indexes. All right, so now I'm going to talk about how do we create indexes from that health check properly. So the missing index section does a good job of recommending indexes. It does not do a good job of analyzing fields and making good multi-use indexes. So this is not really a Cherwell problem. Cherwell is just running the SQL Server reports basically and presenting them to you. So this is more of a SQL Server problem, kind of resolved in some of the newer versions of SQL Server. But and just a quick index field definition. We've got our equality, which is equal, our inequality column, which is everything but equal, so not equal, greater than, less than, and then the include. The include, I say they're optional. The include column basically just says, hey, I was looking for these fields in this query. If they were in the index, I wouldn't have to go to the table to get them, so it does save some time on the SQL Server side. I usually recommend putting them in. The problem is if there's one field in the query that's not in the include, it's got to go to the table anyway. So I usually recommend them for the missing indexes because they're usually pretty specific, and they're probably being run off a dashboard or through some workflow. So they're showing up a lot, and so they're very specific to workflow or dashboard. So I usually recommend adding them. So the first example, we're going to combine include columns. So this is really common. This is where you'll see the same index kicked out 2, 3, 4 times in the health report, and the only difference is the include columns. So this is, I kind of blew up some of these fields so we can see. So if you look over on the left, you can see total cost. I've only got one index over 5 million of total cost. So this is where kind of that fallacy comes in of the 5 million. This was actually from a customer's production site. You can see the second one's 3.7 million, but that query's been run like 7,000 times, and there's a huge user impact improvement. So, and you can see that one's owned by ID. So they just need an index on owned by ID in that case. So anyway, so you can see it kicked out indexes for financial ops linked requests 3 times. So there's 3 indexes it kicked out for just that field. So it's saying 3 different times, 3 different queries came in that were different. They're all different queries. And every time that the query came in, it said, oh, I can run much faster if I had this index. So the only difference between these recommendations are the include columns. So the include columns are different for every query. So you can see rec ID is common across all 3. A service ID is common, and incident ID is in the middle one. Or service ID is common for the first 2, and then incident ID is unique to the second one. So ideally, what you would want to do is you want to create an index field with financial op link requests, and then you could put all 3 of those include columns in rec ID, service ID, and incident ID. The include columns can be in any order. Order does not matter. And they're not sorted in the index, so they just go in. So the next example, we'll look at 3 indexes that are similar in makeup, and they share common fields, and we can combine these 3 indexes into a single index for more efficient index usage. So this one you can see, this is a pretty easy one to do too, but so we can see that owned by ID here is the primary index that's being, or it's a primary field that's being recommended for this index. So that's in the first one. Owned by ID is in the second and third one also. And then we've got this stat incident reopened, which is in the second and third one, and then service ID. So that's saying these queries are coming in like, hey, we're owned by ID equals something. And then second one is we're owned by ID, stat incident reopened, and service ID equals something. And then third one is just owned by ID and stat incident reopened. So you want to create an index that will cover all three of these queries. Now you notice that the order that they're in, owned by ID, stat, incident, reopen, and service ID, is just the order the fields were created. And then you notice status is in the inequality. So they're probably doing something like not equal to closed. So if you actually put that status in the index, that will help. That's why I always recommend putting that inequality in, because then the field is in the index, and the analyzer can look at it once it pulls up all these records, and it'll just drop the closed ones out. So in this case, you want to create an index that's got all three fields plus the status in the index fields. So we've got owned by ID, stat, incident, reopen, service ID, and status. And then the include column. So I would put the include column from all three indexes in there, just combine them all into one. So then those are three separate queries, but then it doesn't matter which query runs, it will always use that index. And what should be the order of this? I would probably do owned by ID first, just because there is a query that's got only owned by ID. And so if we said, oh, let's put stat incident reopened first, then that first query that is only looking at owned by ID, it can use that index. It's just not going to be as effective. So that's what we want to do with those. And then where should we add the indexes from? So this is maybe an older question, but especially when a lot more customers were on-premise. So this is really only a question if you're on-premise. But the preferred method is to add them from Cherwell. So this way the Cherwell admin can see which indexes already exist on the server. And if you add them from the SQL side, the indexes that are in SQL Server will be dropped if they're not in Cherwell. So you don't really want to add them from the SQL side. I have run into some customers where they don't have the DDL rights to create these indexes, and they have to have the DBA do it. So it's a pretty rare case, though. All right, let's talk a little bit about the SQL Server index types. Some of this, especially as you get bigger and more data, some of this becomes important. I'd say if you're under 100,000 records in your main data tables, this probably isn't that important. But as you get closer to 1 million rows and incident and maybe tens of millions of journals, some of this stuff becomes really, it's really kind of techie SQL Server stuff, but it becomes really important. And the way they architected this Cherwell database wasn't necessarily architected for big data customers. So there's just some things that you can do to clean that up and make it more efficient. So there's a few different types of SQL Server indexes. The primary two I'm going to talk about here are clustered and non-clustered. Clustered just means the table is sorted by that index, and non-clustered is everything else. So the clustered index is the most effective index. It's the most efficient because no row ID lookup is required as it is for regular indexes. The clustered index value is stored in every other index as a pointer value. So in every, without fail, and out of the box Cherwell, every single table has got a clustered index of rec ID. That's just how Cherwell works. So that rec ID is stored in every other index in the table. So rec ID is kind of the out of the box clustered index. The entire table is sorted by clustered index. So general guidelines around clustered index creation, if I was developing the system from scratch and it said how do I want to make my clustered index, it should be unique, which rec ID is. It should be sequential, which rec ID is sort of. It's sequential. The first it's 42 characters, and I believe the first 16 are sequential. Then everything's random after that. It should be as short as possible, where the rec ID is 42 characters, which is huge in clustered index, the clustered index world. It's best if it's an integer, which rec ID is not. It should not change, which rec ID never would, so that's good. And it should be a single field, which rec ID is. So rec ID meets maybe about half-ish of these kind of best practice how to make a clustered index. But there's some architectural issues with GUIDs as clustered indexes because they're semi-random strings of integers and characters, and the length. SQL Server will attempt different plans to mitigate that using a lot of CPU time. So imagine thumbing through a phone book looking up last people's names that have random strings and 42 characters long. So that's what the SQL Server has to do with these GUIDs. So and then every other table or every other index on the table includes the clustered index. So you do add quite a bit of size to your other indexes because every column's got that additional 42 character index on it as kind of this clustered key pointing back to the table. So if you're having problems, and you may notice this, and this is really going to manifest itself for, say, 1 million incidents or more, a couple million journal records, tasks, I see it a lot of if you have a few million tasks. For on-premise customers, they'll notice high SQL Server CPU usage. And it will be on queries that are like, select these fields from task where rec ID equals. And it's the clustered index query, the clustered index key, but it'll show like almost all the CPU usage on that SQL Server using that query. You'll have fragmented indexes, and you'll have really high cost for index queries. So you'll see the cost is really high for an index query. So I did have something in for Cherwell development to replace their GUID with a sequential GUID, which is it's still not great, but it's better. But they shelved it. They didn't want to mess with their GUID, so it wouldn't have made a huge difference. But it would have taken care of some of this database fragmentation you see. So do I care about this? Should I change it? What should I do? The bigger the data you have, the more important this is to take a look at. Unfortunately, the bigger data you have, the longer this takes to implement. So if you're kind of newer and think you're going to have a lot of data, the earlier you can do this, the better, just because of the process you have to go through the changes. The process is simple. The time it takes to changes can be long. So what I look at is the table large. So the more rows the table has, the more important this is to replace the clustered index. So I kind of use million as a benchmark, but for sure you should start looking at 1 million, or if you think you're going to hit 1 million, and that would be like 1 million incidents, 1 million journals, kind of depends on what it is. If you're on premise, your DBA is complaining certain SQL queries taking a ton of CPU that can't be fixed with indexes. So you can't fix these with indexes because it's already kind of an inefficient index. And is table used a lot? So journals, CAS, incidents, things like that are used quite a bit. This is going to make a big difference, especially on lookups and looking up multiple records. And then what do I do with journal? Journal is kind of a problem for a lot of customers because you can't move away very easily from that clustered index. So adding a counter field is probably your best option to the journal, just adding a counter and making it an integer and making that the clustered index. And an identity column would be the best, like the best SQL Server solution. Unfortunately, Cherwell does not support identity columns. So an identity column is essentially an index on like a counter, but SQL Server handles the population of that field, so you don't have to do it from Cherwell. But I tried that, and Cherwell actually puts a null into that column, and that breaks it on the SQL Server side. So the only way to make that actually work is to put it in and not have the metadata in Cherwell for it. So kind of put it in behind the scenes. So it's journal. If you have lots of journals and you're seeing the poor performance, selecting those, you may want to go to a counter field. And of course, you'd have to update all your existing journal records with counter numbers, which can take some time. So switching to clustered index, in this example, I'm switching it from rec ID on the customer to phone number, which would be unique in this case. And another thing about clustered index is if you do a lot of lookups on a field and it's unique, that's a potential for clustered index. So in this case, customers looking up, or the user, a Cherwell customer is looking up their customers by phone number. So it makes sense to make that clustered index phone number since it is unique. They don't have to be unique, but it works best if they are. So you just uncheck clustered index on rec ID, find your phone number column, check the clustered index, and then publish your blueprint, and that will change the clustered index. So it can take some time. So switching the clustered index can be time consuming. The entire table has to be rewritten in a different order. So remember, we talked about clustered indexes. the table is sorted by that index. So when you switch the clustered index, it has to rewrite the table, like the physical structure of the table on disk changes. So small tables go fast and large tables take much longer and should be done after hours. So I don't know, Laura, if any questions have popped in that we want to take care of.
We did have one that came in a few minutes ago.
Okay.
It's from Garth. The question is, how do you resolve the issue of the administrative login for the database requires the view server state permission in order to evaluate this rule? He mentions this is for a hosted environment.
Oh, if it's for hosted, contact support. They set it up wrong. If you're on premise, contact your DBA. Then your service account needs that view server state in order to run that. Boy, if you're hosted with Cherwell and seeing that, that's just a miss on hosting. You know, they have a checklist of things they have to do, and that should be done. And it's not. Chances are you're a longtime customer, and they moved you from their data center in Dallas to AWS. That would be my guess if you're a hosted customer and see that. But if you're on-prem, talk to your DBA. So there's nothing you can do in Cherwell for that. That has to be done on the SQL Server side. It is like a SQL Server security thing you have to give to the SQL Server login.
Okay, another one just popped in.
Oh, yeah.
If you want to take it before you keep
Sure.
going. Can you guess how it would improve if I set the cluster from like incident recid? So just incident recid. Why don't you read that question? It's from Marcel in the chat.
Okay, let me pop into the chat here. From like incident rec ID to just incident ID. That's a good question, and that is a good idea. So that's your typical best bet for clustered index. So, and how will performance improve? You know, it really depends. It depends on the SQL Server speed. Overall, you're gonna get an improvement of using incident ID for the clustered index instead of rec ID. One thing is a lot of people are searched by incident ID. They punch in an incident number, and when you do that, and the clustered index is rec ID, you know, your incident ID index then just is a pointer to rec ID. So I do recommend kind of best practice for bigger data customers to swap the clustered index from rec ID to basically the ID of the incident or the change or the task. That's kind of best practice. So Journal doesn't have one, so that's why I spent a little time on Journal. But that's your go-to clustered index. So will you see a big performance improvement? Probably not from the front end. What it's going to do is just going to take a big load off of the database backend. So you're probably not going to see a big thing. Oh, and Gar said, yeah, they did move us a few. He put works ago, but I'm assuming he means weeks ago. So, and then Jeff asked, is it okay to add inequalities to existing indexes for newly suggested rules? Yes. Yep. Add the inequalities to the existing indexes. So I think what Jeff is asking is it's kicking out an index recommendation, and he's seeing like the index fields already have an index, and should he add the inequality that's in there? Yes. So it's fine to add that. It's not really used in the like finding, quote unquote, finding of the records, but it is actually used once it's found the records, then to drop the records that don't match. So, and it's a much smaller. If you didn't have that in there, what would happen is it would plow through the index, get the records that it needed, then it would go to the table and it would look up that status or whatever the not equal is, and pull it out of the table. So it's a lot of extra work if that inequality is not in that index. So that's a good thing to do. Oh, incident ID versus rec ID. Yeah. Yeah, it will. Well, it will keep it does put them in order then, right? Because it is a counter number essentially with that little prefix. So it doesn't necessarily keep open incidents together, but I like incident ID versus rec ID for the clustered index regardless. So kind of best practice. It won't break anything in Cherwell. You still want that PK. It's called PK rec ID or whatever they call it. You don't want to get rid of that index if you switch to clustered index. You still need that index for some other lookups that, especially like on these foreign keys. But I'm a big fan of changing the clustered index to the incident ID. Okay, so what let's go over a little bit about what are these VLD IDs. So on older versions, you'll see this a lot more. Newer versions that kind of fix this. Oh, Sean wants to know where you add indexes in Cherwell. Okay, thank you, Marcel. So you may see these in there. In pre-9.6, you can only add these via SQL Server. So if you're on pre-9.6, you have to index these via SQL Server. If you're hosted with Cherwell, they will actually add these indexes for you. If you're on premise, you'll have to have your DBA add these indexes. If you're on pre-9.6, you must re-add the index after every publish because Cherwell will actually drop those indexes because they're not in Cherwell. So now in 9.6 and greater, the VLD ID column should be indexed when you add the field. So in this case, it's incident type underscore VLD ID. So if you add this is an incident. If you add an index for incident type, it will add. It's smart enough to add the incident. It actually won't add the incident or the index for incident type, which kind of stinks sometimes. But it will add this index for incident type VLD ID, so that will show up. So, and what those are, they are Cherwell's foreign key implementation. So instead of using like SQL Server's implementation of foreign keys, which would have been better in my opinion because they only use SQL Server as their database, so why not use that feature? They implemented their own version of foreign keys, which it's like application level foreign keys, which if you dealt with these, they're kind of a mess. So, but that's what they're for. So incident type, it's kind of silly, but instead of searching for incident type, it searches for the foreign key, which is the rec ID on the incident type table, which isn't ideal either, but that's just how it works. So and indexing a rec ID is better than no index. So that's what these VLD ID fields are. So index rebuilds, this is just for on premise. Hosted does this. They have a process to do this, so they're already doing this for you. But basically, these indexes will become fragmented. If you think about an index and how it's written, so for example, if you have an index for phone number when you're adding customers, SQL Server uses this concept of pages, and it'll fill a page full of data. Once the page is full, if something else needs to be stuck into that page, it builds like a little B tree, which is kind of like a branch off of that page to another page. So essentially, these indexes become fragmented, and instead of scanning like all these pages in a row, it has to scan these B tree pages, which are secondary pages. And so it's better if you do these index rebuilds. So if you're hosted, these are being done. If you're on premise, these should be done occasionally, monthly. I would do it monthly. Just rebuild all the indexes monthly. I say they're almost unnecessary on systems with all SSD storage, and that's because all SSD storage doesn't have any moving parts. The fragmentation doesn't affect it as much, but it's still these logical reads are still more difficult than if they're sequential. So I still recommend index rebuilds every month. Okay, so some other index options. So this is for maybe bigger data customers. Cherwell doesn't support these, so you might be, if you're on premise, you can do these. If you are hosted, you can still do these. It's just a little more difficult because they get dropped, and Cherwell won't necessarily support them. But they're just better indexes. This is really advanced tuning for SQL Server now. So filtered indexes allow you to create indexes with only the data that are commonly searched. So like if you had an open incident index. So that would be all the incident where status is not equal closed. So it would actually be all the ORs, right? So you would create an index that would only have open tickets in it. So then when all those open ticket indexes come in, it will use that index. And if it's searching for other things in there, say like owned by team, it will only search that index. So the index is just a lot smaller. It takes up a lot less space. And if you have to do an index scan for some reason, it's a lot smaller index to scan. So not supported by Cherwell, so it must be regenerated after Blueprint publishes of the object. So you'd have to create this one manually in a SQL editor and create the index. It's pretty simple, but after publish, it will get dropped, so you'll have to re-add it. Now, I think maybe, I don't know if someone knows, I think Cherwell fixed that in really recent versions, where if you have indexes that are not in Cherwell but are in the SQL Server database, I think in some of the 10.2 versions maybe they actually fixed that. So the column store index, my favorite index, best for tables with 1 million rows plus, although we'll work with less. Column store indexes basically sort records by the million. So every million rows gets its own like section of the index. You can index every column in a table in columns instead of rows. So these column store indexes, they don't look like a spreadsheet like a regular index does. It looks like like a spreadsheet turned 90 degrees. It looks like they're stored in columns instead of rows. So this is really great for like looking for grouped data. So column store indexes are also stored in memory. So they're extremely fast. They're extremely efficient for range scan. So column store indexes basically turn your Cherwell database into like a data warehouse. So not sort of Norman's asking more like an array. Not even really like an array. It's more like it groups like dates together. So if you're looking for a range scan, so tickets open since, the column store index will have like all of the dates together. So it's storing that like values together. They're compressed by an average factor of 10 times, so they're extremely small. You don't have to have all the fields in there, but sticking all the fields in the column store index makes essentially any field searchable. So you'll still see, like if you look at the optimizer, you'll still see like, oh, it did an index scan, but it's in memory on compressed data. So the amount of data that it's scanning is the same, but it's really fast. So also not supported by Cherwell's admin toolset, so must be rebuilt. So if you're interested, do some looking on column store indexes. Just do some Googling on that and see. I will say, it's for the million plus tables, and it really helps out on kind of big range scans. So if you're always looking at like reporting on dates. So anything that has a range, it really excels at. So if you're looking at like this month, last quarter, last year, or if you're looking at, give me all the tickets owned by these 52 teams. So anything that has a lot of range will really benefit from these column store indexes. And like I said, it turns that table. So you make them by table. So like you can add one to incident. It turns that incident table really into a data warehouse. And one of the nice things is most queries that don't have an index will end up using this column store index because it's so darn efficient. So efficient and so fast because it's all stored in memory. So you can fix a lot of problems with a single column store index on a table. So there's a lot of complexity behind the scenes on these. You may talk to DBAs that say, oh, no, don't do a column store index. They have really changed quite a bit in the last, say, 5 years. They used to be static. You couldn't update them. But now they pretty much work like a regular index now. I really don't see much downside of using these other than they take quite a while to generate because it is a copy of your table. But once you've got it, the performance that they have for like running reports against the database is pretty high. And because they're all in memory, you're not fighting for disk time with your regular queries and your regular inserts and updates. So they are pretty impressive. I really like these things. I wish Cherwell supported them so you could add column store indexes from Cherwell, but right now you're kind of stuck adding them yourself. You can add them with the blueprint publish. You can write the column store index DDL and do it. So yeah, Patricia. Pat, hi. Yeah, she asked it if they're only available for on-prem customers. You can do it if you're you can add them if you're hosted. Cherwell won't really necessarily, something happens to it, they won't really support it. They'll, you have to be careful because it'll get dropped after every publish, and they do have to be rebuilt, and they can take a long time to generate. So this is this can still, they can be an issue on hosted. So I don't think we have any customers running column store on hosted. I know we have some on premise that are doing it. So Norman asks, will Cherwell performance check still make unneeded suggestions if you use column store index? So if health check does make a suggestion, you may still need to add that index. So generally, because this column store index is not technically indexed, it's just a copy of the table in memory, so it's super efficient. You still may need or want to add indexes, especially for large sets of tickets that aren't in a range. So it'll still kick out index recommendations, and then the problem is without having access to the SQL Server and actually running those queries and seeing what the cost is to run it in the column store, it's difficult to make that decision on whether or not to add this index. So generally on a column store index, it's going to be so fast for a full table scan, you don't need an index. So kind of a sweeping statement is if you have a column store index on a table, you probably won't have to add other indexes to that table, because now SQL Server isn't always going to use the column store index, and that's kind of the black magic of SQL Server. So that's where you kind of have to dig into that query section of health check and see what the cost is and the CPU time and all sorts of things. So if you're on premise, play around with it in test system and see what happens. They're pretty impressive. I really like them for big data customers. So what is Matt saying? Imagine that objects would have some non-unique values, making it a clustered index. Oh, yeah. So non-unique values. So you can make clustered indexes out of anything, really. But there's not a lot of advantage of putting multi-fields into a clustered index, especially on a small table. The overhead on it is pretty high, so I would generally try to stick with integers or ticket numbers for clustered indexes.
Eric, we've also got a question from Garth that came in around 10:49 your time.
Hmm.
Put an update up there, or I can read it too. Included a
Oh, okay.
screenshot.
Got a picture too. When do we need to select it if an index is primary key or clustered index or unique? Oh, so okay. So primary key and unique, sort of the same thing, but primary key actually creates like a primary key flag on the system. Primary keys don't have to be unique, unfortunately. Unique you would want for things that should be unique. So, for example, Cherwell's indexes on incident ID is not unique. So, if you're a big API developer like me and accidentally forget to put in the header of that JSON the ticket ID and put it in the body of the JSON instead, it will actually create, instead of updating that incident, it will actually create another incident with that same ticket number. So you can actually create tickets in Cherwell that have the same number as other tickets, which I'm sure was not Cherwell's intention, but they never put that unique flag on the index. So you want to put that unique flag on the index if it should be unique. So all of your ticket numbers should have that unique flag set. None of them do. One nice thing about setting that unique flag is if you're searching for, right now, if you search the database for a ticket number, Cherwell will, let's say you don't have an index for incident ID, which would be silly, but let's say you accidentally removed it. It will actually scan the entire table for that incident ID, even if the incident ID you're searching for is 1 and it finds it right away. It'll search the rest of the table for it because it doesn't know that it's unique. Now, if you check that unique flag, as soon as it finds that incident number in the table or in the index, it stops looking. So you can save a ton of time on these queries on these unique fields if you actually mark that unique flag on the index. So I should maybe put that in my presentation because that's pretty important. And how these databases work is if it's not unique, it'll just look in the whole index or the whole table for that value because it think, oh, there could be 10,000 of these tickets with this number because it's not unique. So the primary key is essentially the same thing, but there's some behind the scenes SQL Server stuff that it also does. Like you can link foreign keys to the primary key and things like that. So, but once again, primary key doesn't have to be unique. So I would set, you can only have one primary key per table. So primary key is always going to be rec ID, unless you change it to, you could change it to incident ID if you change the clustered index to that, and then also set it to unique, which is going to be your most effective index. These are incidents on the incident business object, and there's only one index ticked with primary and clustered index ticked. All the others are. You can only have one clustered index and one primary key index per table or per business object. You can have as many unique indexes as you want, but make sure they're unique. So I don't know why that's not checked on ticket number, but it has caused me some headaches on the API side when I make mistakes. Instead of telling me that, hey, you can't create another incident with the same ticket number, it just creates it for me. So, all right, let's talk a little bit about application tuning. There's a few tailoring things to watch out for. One steps, there's ample opportunity to create poor performance because one steps provide the opportunity to reload records and save records. And some people do that on every panel or every other panel. If you don't have to, you can avoid this. So this is like a set pending example. So you can see, like we did this for a customer. Set pending, I think they fixed this in later versions, but earlier versions of the set pending one step, they just have all these saves in them that don't have to be in here. So for example, this set pending in the top example, we removed 2 saves kind of in the workflow and just added a save to the end. And then there's some other, and then I think it keeps going here. So then this panel reloaded the record, and then this panel reloaded the record, and then this panel had a save in it also. And then there was another panel after that had a save. So, that reload record and save record, that panel, those checkboxes that you have in the one steps, sometimes you need to use them because some things in Cherwell are calculated on save. But generally, if you can avoid using those, avoid them because saving an incident 3 or 4 times during the course of a one step, if each save takes a half a second, and you do it 4 times, well, that's 2 extra seconds on saves that during that one step. So this one step, I think it was taking, I don't know, Bill fixed this one. I think it was taking 30 some seconds to run. And first thing we did was index the queries that were being run. We got it down to like 11 seconds or something like that. And then we took these saves out and these reloads and we got it down to like 2. So we went from like 30 some seconds to running a one step to under 3. So you can fix these one steps. You kind of take the time to go through them and figure out what's wrong with them. Just
We've
a
got
few
a
other
couple
tips.
questions too,
Oh,
Eric,
yeah.
that just
Okay.
popped up.
All right. What if there's no
Sean.
missing index recommendations in the health check? There's a couple options. Either you don't have that view server state, but you'll usually get an error. Sometimes you won't. You're on test and you've just never run any. You just haven't created any tickets or run any queries or anything on there. And a lot of times in test, not a lot of people are using it. So everything you're doing is probably already indexed. Third option is you just don't need any indexes. That's pretty rare. I normally don't see that in production. Usually in production, it's kicking out something. It might be really minor, or might have an additional field in the include column. So either you ran it on test and there just isn't enough load to kick anything out, or you don't have that view server state. Oh, on the first pick would have made a difference if you kept the save on the service cart workflow instead of making a new save step. Boy, maybe. Yeah, potentially. I'm not sure. I didn't do this one, so I'm not sure why the save is at the end. But essentially, yeah, if that save was on the service cart workflow set to pending 22, that it would be the same as adding it at the end. I think we just put it at the end in case they wanted to put some other stuff in the middle there. And I don't do a lot of one-step programming, but I always like to have a save so I can see where the save is at. So I like to add a save panel just because then I know where it's at. I don't like to do the save on the, like, check that checkbox, just because it's difficult to know if that thing's saving or not. So that may have been what Bill did there. So application tuning, first tab. So Cherwell, and some of the stuff is kind of fixed in newer versions of Cherwell, but if you're still kind of on their older format of tabs, when the data was at the top and the tabs are at the bottom, whatever's in that first tab is going to load. And if it's a bunch of related records, the record won't show until that loads. So I think out of the box, journal might be the first one, or tasks, and some people move them around. So make sure it's not like journals or tasks on that first tab, because if they're not, then you can actually get it to load when you click on it, which may take a little delay when you click on it, but the record will load in the foreground without loading those. That load keys whenever possible for one-to-many, load keys only. That will just load like the relationship keys in and not everything. So it's pulling a lot less data. So that's something you can try. Depends on the version of Cherwell if this is going to work or not. And if you're doing something with those records, like in a one-step, let's say you're cycling through journal records in a one-step on the ticket, if you have load keys only, those fields aren't going to be available for that one step. So it can cause some issues if you're doing some kind of out of the ordinary type things. So you really have to test that. But we have seen some pretty good performance improvements, doing load keys only instead of load everything on those relationships. Don't load when constraints are blank. Kim gave me this one. I still don't understand it, but I think essentially if there's no records, then it just won't load the relationship. Application tuning journals. So journals, holds probably the most information in the system. So one thing we've recommended is splitting the journals into two relationships. That can help. So don't modify the currently used journal relationship and then one for the audit. So you can have like a relationship for audit and one for what users care about. And then you get into archive and purge. So, Cherwell is supposedly coming out with some archive functionality, hopefully next year. But you can do some of this yourself. You can't really do archive, but you can do purging. So good practice well, you can do some archiving. So we have some examples of like potential archiving things you can do here. So like archiving approvals. It involves removing the parent rec ID and adding a history ID to it. Does not change the number of records in the table, but it does reduce the number of records pulled in for approval queries. So if you remove the parent rec ID and add a history ID that references that same record, you can kind of change how many records that query pulls back. You can archive supporting data. So are all email tickets required long after a ticket is closed? So do you need the email, like the trebuchet mail records? That only really happens when you click the email and want to see the actual email. So those are stored. The execution of Cherwell automation processes, a lot of those stick around. Cherwell keeps records of the process that's having run. It also keeps journals of mail history. It takes up a lot of space. And review closed records for cleanup of old data. So we do have some customers that are purging data, after 3 years or 5 years or 7 years. Time to archive primary data. So develop a company strategy for archiving. How long do the records need to be maintained? How many records are processed per month per year? And do you need to be backed up to an alternate system? So you can schedule weekly, monthly, or yearly one steps to target these records and backup and or delete. So like, for example, I think I have an example. Oh, I don't. Okay. So like if you wanted to archive your journal records, basically, you could create like a journal to table and like actually physically move them out of the journal table into journal to, or journal history, you could call it. So you have some customers doing that. That keeps your journal records small. You keep the journal records attached to the ticket. You have to have another table and another relationship. But that can help on pulling journal records into tickets. So say maybe after a year, or maybe some customers even do it after the ticket's closed. They move all the journals to this journal history table. So then only open incidents have records in journal. So you can do some things like that to kind of mitigate some of these large data issues that you're having. It is quite a bit of work because you have to create the new object and the relationship and the one step to move the data over and delete the old data. What happens if you reopen a record? So there's a lot of things to take into account, but some of these things you can, in order to get better performance, you can do this. And a lot of the performance issues you can fix with indexing, but a lot, once you hit, if you're at 40 million journal records, you might want to think about maybe archiving some of those off into another object. A little bit of IIS tuning, and I think we're about done. So this is going to be only for on-prem. So there's some things that you can do. You need to make sure application initialization is set. So this is really going to affect like the first time somebody hits like the portal or the web client or your API. So these are all IIS things. So everything web-based in Cherwell. So make sure application initialization is, and Cherwell support and hosting should have these set properly. But if you have like your first shift comes in and the first couple of people complain that, hey, or people in the morning complain that, hey, the portal takes me 2 minutes to get into the portal, then you might want to check with Cherwell support to make sure they have these checked. So, and I have screenshots of these, so you can reference these and talk. If you're on premise, you can talk with your server admin to make sure these are set. If you're hosted, you can talk with Cherwell support, make sure they have these set. So this app initialization, this I normally do see set. So a lot of times will be set. That has to be checked though for these to work. And this is on the add server roles. And then there is start mode. So on the application pool, so not in the site, but the app pools, you want to go to app pools, advanced general, and the start mode you want is always running. The other option is on demand. So that's the problem where in the morning, this thing is cycled overnight. In the morning, somebody comes in and they hit this website, they hit this portal, and it takes forever to log in. And that's because it's set to start up on demand. So if you leave that as always running, it will start when IIS is recycled and it'll be running all the time. So that's an important one you want. That's a big delay one, especially in the mornings. This is a little blurry, but the idle timeout action, you need to change for each of the app pools. Set it to suspend. So this is what happens if that IIS app is idle. It'll either suspend it, which basically it just kind of pauses the process, or it will kill it, and you want it paused. So you want this set to suspend. So this is the idle timeout action. The do app init after restart, you want to set to true. So what that'll do is it'll initialize the application after IIS is restarted, and that's important so that application actually is initted as soon as that starts up. So you have to, so that with the combination of what happens, like the always running, that will make sure that application's ready for the first people that come in and hit the portal or hit the Cherwell web client every morning. So that's an important one. And that's it. So, and I'll say this IIS tuning that I throw in at the end, most on-premise customers get like the most value they get out of this presentation is this IIS stuff. So even though I have it at the end, if you're on premise, probably these are set incorrectly. And you want to go in there and change those. So is it normal to have over 1,000 recommendations for foreign key configuration section on the health check? I would say yes, because our out-of-the-box 10 versions of Cherwell that are just sandboxes have tons of those foreign key configuration checks. And I don't know how to fix them. Like I'm not really the top Cherwell, like I work on our our mobile and Kanban, so we do a lot of API stuff. So I'm not intimately familiar with those foreign key things, but I generally uncheck that when I run the health check because it can take a very long time to run, and that I don't understand what those are. And if you're curious, I ran this health check before we started. I'm curious to see what this is on our public demo system for our mobile. So so you can see I've got 28 gigs of RAM allocated to this, which I don't even think is right. I have 48 gigs of RAM allocated to the SQL Server. I think maybe I changed it. So let's see if oh, you know what? I did not run, or maybe I did. Let's check. Let's see if we've got those crazy foreign key things in here. Yes, here they are. So this is on an out of the box 10 something. Look how many I have. It's a lot. Now this was upgraded from 9.3.2, so I should say it's out of the box, but I did not do the content upgrade. I just did the binary upgrade on this. So maybe that's the problem. Boy, I've got a lot more than 1,000. So Vance, I think I missed what you said about IIS. There's some notes that will be shared. Would be great. We're on-prem. Yes, Vance, you definitely want this presentation. Go to the very end of the presentation, and the IIS stuff is in there. So you can contact Laura she can send you a copy of this, and you can take a look at that. So, yeah, I didn't uncheck any of this stuff. Let's see if what it kicked out for. So here's the queries by CPU time. So there's lots of stuff in this health check that like a DBA would love. Here's queries by read. Like this one's run 891 times. Let's see if it kicked out any indexes for my public demo system. Here's by row counts. You can see, oh, I've got 7,500 rows for journal. There's some neat stuff in here. Here's a seek and scan. So I've got this history type right here. It's been updated only 48 times, but you know it's never been used, so I could probably get rid of that index. There's some mismatched def IDs. Oh, I got to get past this foreign key stuff. Perfect. This is why you want to uncheck most. If you're doing just performance, you want to uncheck basically everything except the missing indexes. Oh boy, lots of problems with my demo system. All right, here's the missing index rule. So this is the part you want. So even though this is just our public demo, it's rarely used. I've done quite a bit of tuning on this. It is still kicking out indexes that I could potentially have in here. I think I've only got like a couple hundred incidents in this system. So, but you can see there's still some pretty impactful, like owned by team and status. I'm sure I have an index for owned by team. Probably it's because of these include columns it's asking for. Being on premise, I can just stick these. I can kind of work my way back, find the queries, and then see if the index will actually help or not. So I'm still getting some, and I probably haven't tuned this since I went to 10, and it added all these foreign keys. So now I've got like these foreign keys that I should add. Lots of status VLD IDs. These are probably out of the box queries that are being run with not equal to. So I could go in here and tune this. It's not really a big deal. We don't really have performance issues on this system because it's so small. But you can see that even on this fairly tuned system, I'm still getting some recommendations. So if your system says no data, is this production or a test that you're running it against? Sean C. I don't know if your name is. It must be Sean, since there's no comment there. Going live in about 2 weeks. Okay. Good question. Are you on premise or hosted? I think you said you're hosted, right? Yeah. I would check with Cherwell and just make sure, and just tell them you're not seeing anything in there, and just make sure that you're set up to run that. It really should have something. Unless somebody's been monitoring this and tuning it as you go along, it's possible you don't have any, but you can see I've got some that I know I have indexes for. Like I know I've got an index for owned by team, and it probably has status in it. but it's probably missing one or two of these include columns, which is why I threw it in there. So you'll generally see at least those. So my guess is that it's just not set up right for you to see this stuff. I would talk to Cherwell support about that and say I'm not seeing any missing indexes. And one thing you can do is you can run a query that you know is super inefficient. Like just pick a random field that has data in it that's not indexed, and pick a value in that field. And so select all the records from incident where sysmod time is greater than this date, right? I don't think sysmod time or last modified date time. So pick, do something against like one of those date fields that's not indexed. You'll want to check the object to see if it is indexed or not. Run that query and then just run the health check again and see if it shows up. Like that would definitely, doing something like that would definitely kick out an index recommendation. So if you do that, it'll kick it out right away. It'll show up right away. So run that query and then rerun the health check. And if it's still blank, open a ticket with support and say, I'm not seeing missing indexes. The other thing to check is, well, you probably don't have these either, but it should kick out the top 25 queries by cost and CPU, which is more up at the top here. So if those are blank also, then you definitely have a problem because these aren't necessarily poorly performing. They're just the worst 25 performing queries in your system, or top 20, I guess. So you should have the top 20 queries by CPU time and the top 20 by average read. So if that's blank too, then either you've just never done anything on this system, or chances are it's a security issue with their backend database. Oh, it does have those. Oh, interesting. I'd still run a query that I know was bad, and then just to validate, and then open a ticket with support. Okay. Any more questions?
I haven't seen any more yet, so I think this will probably serve as last call if you've wrapped up your information today, Eric. So if you have any questions, now is the time. We'll leave the lines open for another minute or two, just in case anyone does have any final questions before we hang up. And if you have any ideas of future advanced practitioner topics, things you would be interested in seeing Eric or our team cover, I would love to hear your insight as well. We're always looking for information that we can share to connect with everyone. So if there's any topics Cherwell related you'd like to learn more about, let us know. I'd love to hear your ideas. Okay. Looks like there is a question from Charles. What is the difference between quality and inequality for usage?
Oh, yeah. What is the difference between inequality or equality and inequality? So if we take a look at that that missing index recommendation, which is down here, you'll see that it's got inequality and equality. The equality basically means equals. So if we take a look at this column, this equality usage, everything in here in the where clause said equals. So here the query would have said owned by team equals something. Inequality means not everything but equals. So for example here, this says owned by team equals team 1, 2, 3, status not equal to something, probably not equal to closed, right? Over here, for some reason, we're looking for things not equal to title. And then the include columns, they're not in the where clause. So this is always equal. This is always, it's not always not equal. So for example, it could be greater than or less than, but it's going to be something besides equal. And greater than and less than can be indexed and can use an index. Not equals cannot use an index.
Okay. There was a couple questions about the recording. So everyone who's registered today will get a copy of the slide deck. I'll email that out to the whole registrant list. We also recorded today, so that'll be sent to our entire database, whether or not you registered. So everyone attending here will get the recording, and anyone else from the organization that we know of will receive the link to the recording as well. It takes us a couple of days to get it converted and uploaded to our website. So within the next couple of days, you should see that recorded link from us. Okay, I don't see any other questions, Eric, so I think that'll be a wrap for us today.
Okay, thanks everybody.
All right, well, thanks for the information. Thanks for joining us, everyone. Hope you'll make it to our next event. Have a great day. Bye-bye.